The Kestrel Bicycle Company sells mountain bikes and road bikes that come in red, black, or green and come in either medium or large. So how many styles are available? Well, it comes in mountain bikes or road bikes, so that those are 2 styles. How many colors are available? There is red, black, or green. That means there's 3 styles available. And how many sizes? There's either medium or large. Those are 2 sizes available. So we're going to make an organized list to determine how many different bicycles are available. There's different ways of calculating this, but we'll actually look at 3 different ways. One of them is using an organized list. So if I start off with, let's say I know my mountain bikes, and I'm going to call this M. And actually, if I make it organized like this, where I have the style, and I have the color, and I have the size, make an organized list like this. So my style is a mountain bike. Here's one of them. And then the color, I'm going to have red. And the size, I'm going to have medium. Now I can have the same bike, a mountain bike that is red, that is large. There's another one here. And I'm going to ask you to go ahead and continue until you have all the different possible bicycles that are available. See if you could make that whole list and then check back with me here. So when I finish making all of the different possible bicycles in there, I end up with 12 possible different bicycles in there. So that's basic. That's one way of determining how many different bicycles are available, is using this organized list. All right, so I can also use something called a tree diagram. Okay, and this is something, there's different ways of doing this. We need to have the skills to be able to do all of these. All right, so with a tree diagram, I'm going to start off with, at the top, I have 2 choices because there are 2 different styles. I have a road bike and I have a mountain bike. And I give some space here between them because of the way this tree diagram works. All right, so then for each road bike, I'm going to have 3 different colors. So I'm going to go 1, 2, 3, and the mountain bike are going to have the same 3 different colors in here. And we're going to have red, black, and green. And red, black, and green. All right. And then each one of these colors has 2 different sizes coming off of it. So it's going to have a medium and a large coming off of each one of them. So this is using, so we have medium, large, medium. You can write the whole word in there, but particularly when I get down towards the bottom, I don't have really room to do that. So I'm just going to use the letters M and L. And there we go. We can see in here now, as we do this, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Just to show you how those bottom letters became one of the choices. The first choice in bicycle is this group right here, road, red, and medium. The second choice would be road, red, and large. So there's 2, and so you can see each of the bottom ones indicate a new bicycle in there, which is why we end up with 12 in total. Same thing we had with the organized list, but it's just another way of doing it. Okay, if I roll the number cube, which is basically a die, a 6-sided die, and flip the coin, what's the probability that I get a 6 and a heads? But before jumping right to the answer, what are the numbers of outcomes when just rolling the number cube? Okay, so a number cube has 6 sides. I could get a 1, a 2, a 3, a 4, a 5, or a 6. There are 6 different outcomes. What are the number of outcomes when just flipping the coin? There are 2. And then it says, what are the total number of possible outcomes? How do the first 2 answers relate to the third? What is the probability? Okay, so I'm going to really quickly draw a tree diagram to help me out with this. And then we're going to learn a little bit of a shortcut here. So I know when I roll the die, I could have a 1, a 2, a 3, a 4, a 5, a 6. Okay, so the top of the tree diagram is just one of the possible things, which is the rolling the die. And then from each one of those, I can, if I get a 1 when I roll the die, when I flip the coin, I can also get heads or tails. So for each one of these, we're going to have the option of heads or tails. So this is showing that I could get a 1 and a head. When I look at this, I can get a 1 and a head. I guess I'm looking for this thing here. A 1 and a head here, and a 1 and a tails. I could get a 2 and a heads, a 2 and a tails, a 3 and a head, a 3 and a tails. All right, and then continuing on here, I'm going to have a 4 ahead. These are all the different possibilities here. And once again, if I look at, this is one of my possibilities. This is a second possibility. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different possibilities. Okay, so we know the total number of possible outcomes is 12. How do these first two numbers here, 2 and 6, relate to the number 12? Well, hopefully you can figure out, that 2 times 6 is 12. So what is the probability? So I know that there are 12 different outcomes, and really interesting that we can see in this case here. There's a shortcut. I don't actually have to draw this tree diagram to find those 12 choices. I can take the 6 choices of the die and the 2 choices of the heads and tails and multiply those two numbers to get 12. That gives us 12 total choices here, 12 possible outcomes. And the probability now of getting a 6 and a heads, there's actually, in this case here, where is the 6 and the heads, is right here. There's only one of those possibilities out of the total of 12. So the answer is 1 out of 12. All right, so now I'm going to show you a technique of basically finding the total number of outcomes using what's called the fundamental counting principle. So we'll use number 4 to explain this. In the United States, radio and television stations all use call letters starting with either a K or a W, and they always have 4 different letters possible. So we've got, when someone is deciding on their station, they have 4 different decisions. And one of the things that I'm going to write here is I'm going to say decisions. Oops. I'm going to use a circle to represent that decision. So I've got 4 different decisions, and I've got 1, 2, 3, 4. You might want to take some notes of that we're going to use the circle to represent the number of decisions made. We've got to choose, this radio station has to choose 4 letters thing. So it's got to choose the first letter, the second letter, the third letter, and the fourth letter. Those are 4 decisions that need to be made. Okay. And now we're going to fill in each one of those circles with the number of choices that are possible within each of those decisions. So for instance, we know that they always start with K or W. So there's K or W are the 2 things. And that means that there's only 2 choices in there. So the number inside equals number of choices. Okay, so there's 2 choices. Now, only the first letter was restricted to be K or W. The other ones could be any letter whatsoever possible. So within this circle, how many choices are there? Well, it's the number of letters in the English alphabet, which is actually 26. All right, that is actually a good number. We're going to use that one a lot, so make sure that you guys memorize that in there. All right, so we've got 26, and then the other one also has 26 letters because there's 26 letters to choose from, and 26 letters again. And then what we do is we actually multiply, just like we multiplied the 2 and the 6 in the last problem to get the 12. The fundamental counting principle says if we have 2 choices for one decision and 26 for another and 26 for another and 26, we just multiply all those numbers together, and that will give us our total possibilities of getting that, which is 35,152 possible combinations. Okay, a hairdryer has 3 settings for heat, 2 settings for fan speed. Okay, so we have to choose, we have 2 decisions to make here. We have to choose the heat and we have to choose the fan speed. Okay, so we have the circles in there, and then we're going to put in the inside how many choices we have. How many choices do we have for heat? We've got 3 different settings. And how many different settings for fan speed? We've got 2. So then I multiply those 2 numbers, and I end up getting with 6 ways of blowing my hair. Woo! All right. A restaurant offers a choice of 3 types of pasta with 5 types of sauce. Each pasta entree comes with or without a meatball. How many different meals can you eat? So we're trying to figure out, all right, how many decisions am I going to make? I have to decide what kind of pasta. I have to decide what kind of sauce. And I also have to decide with or without a meatball. All right. So now, let's see. We've got 3 types of pasta. So I had 3 choices for pasta, 5 types for sauce, and with or without a meatball are 2 choices. That's with a meatball or without a meatball. Those are 2 different choices in there. I multiply those numbers, 15 times 2, which gives me 30 different meals. All right. We can not just count outcomes, we can also use this to help us find probability. So a probability of winning a lottery game where the winning out number is made up of 3 digits from 0 to 9 chosen at random. Okay, there's 3 digits, so there are 3 decisions to be made. Okay, we have 1, 2, 3. The first digit, all right, well, how many digits are there that could possibly be chosen from 0 to 9? Now, it's really important that we understand that if we count from 0 to 9, that is not 9 digits. I can't tell you the number of students who get that wrong. Actually, the number of digits that are in our number system are based on the number of fingers on our hands, which is 10. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are all digits, but 0 is also a digit, so there are 10 digits. So I'm going to put inside here 10 digits there to choose for that first digit that we're choosing, and then we have to choose another digit, and there's 10 more digits to choose from, and then there's another digit, which is 10 more digits to choose from in there, and then we multiply all of those together, 10 times 10 times 10, and we end up with, there are 1,000 choices. Now, this one is a probability question, though, so there are 1,000 possible outcomes that we could get, but how many of them is the winning number? Well, there's only one way to win. So we have the number of ways of winning, which is 1, out of the total number of outcomes, which is 1,000. So this lottery game has a 1 in 1,000 chance of winning. There's my probability. Okay. A spinner is spun 2 times. Josh says that there's a 1 in 3 chance that both times it will land on red. Explain how he is right or wrong. Okay. So there's a couple of ways of doing this. Let's do this with a tree diagram first. So let's start off with, he's going to spin the first one. And if he spins the first one, there's 3 different outcomes, which are yellow, blue, and red. So I'm going to write in there yellow, blue, and red. So that's the top of the tree diagram. So that's spinning it once. Now the second time, out of each one of these, we could also have yellow, blue, and red. Okay, that's the other possibility when he spins it the second time. So I'm going to add in the yellow, blue, or red as the choices in there. Okay, so Josh says that there's a 1 in 3 chance that both times it will land on red. Okay, so now if I look at that, both times it lands on red, I see only this one. This is the only one where it's going to land both times on red. So that's 1 out of, and how many different choices are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 possible outcomes. So actually, Josh is wrong. It is a 1 in 9 outcome that it will land on red. Here's another way of doing it using the fundamental counting principle. We know that getting a red when you spin it once, the probability of getting red is 1 out of 3. There's a red here, here, and there are 3, so there's a 1 out of 3 chance of getting it red on the first spin. So using the fundamental counting principle, we could also say that we have 1 out of 3 is the probability of getting it on the first spin is getting red. And we also have 1 out of 3 is the chance of getting it on the second one. And then we simply multiply those two together, 1/3 times 1/3, and that gives us 1/9. Okay, so that's another way of doing it. We use the fundamental counting principle. We can also, for probability, just as well as we could use a tree diagram to be able to do that. And we just basically did that in part A in there. Okay, so that we just did 8A. We also just did 8B. I wrote it up here. Fundamental counting principles to prove you're right. What is the probability that 2 spins will land on different colors? This is where it's really easy to use, again, the tree diagram that we already wrote in here. So the probability that 2 spins will land on different colors, well, let's take a look here. We've got, there's 9 total possibilities in here. And how many of them are different colors? Well, let's see, let's use a different color here. There's 1, there's 2, there's 3, there's 4 different colors, there's 5, there's 6. So there's 6 out of 9 possible ones that will land on different colors, which these are both divisible by 3. So if we divide that by 3 and divide that by 3, we will end up with 2 over 3. So 2/3 probability of getting different colors. So that's using the tree diagram. Is there a way of doing this with the fundamental counting principle? So yes, again, we're gonna spin it once, and there's gonna be a probability of getting the correct thing, and we're gonna spin it twice. There's gonna be the probability of getting the right thing. So when I spin the first one, this is a weird question here because the probability that the 2 spins will land on different colors, what's the probability that you get it right on the first spin? Well, the first spin actually doesn't matter because in this case here, there are 3 different colors in here, and the probability of getting a different color, well, for this case, there's actually a 100% chance that you'll get it right on the first one because it doesn't really matter which color you get on the first one. So I'm going to put in a probability of 100% for the first one. Now, once I spin it, and let's say it lands on blue, now for the second one, what's the probability that I'm going to get a different one? Well, there's the only other 2 choices are red and yellow, so there are 2 out of 3 chance of getting it right on the second one. Again, we multiply these 2 numbers. 1 times 2/3 give us a 2 out of 3 probability, again, of landing on 2 different colors. Okay, so that's using the fundamental counting principle in the second part here, and back here we were looking at the tree diagram to be able to come up with that answer. All right, now I'm going to have you go ahead and try to answer questions 9 and 10 and check back with me. So let's see if what we've learned about this fundamental counting principle to see if you can figure out the answer to these 2. All right, so for the pizza question here, we had 3 decisions to make. We had the kind of crust, which there were 3 different kinds of crusts. We had the next decision, which was the kind of cheese. There were 2 different cheeses. And then we had which toppings, which were 4 different toppings in there. We multiply those together, we get 24 different pizzas. The number 10 was a little bit of a trick because the Social Security number has a lot of numbers, but this was only looking at the final 4 digits or random numbers, and the question says, how many possible ways can the last 4 digits be assigned? Okay, so here's 1 digit, 2 digits, 3 digits, 4 digits, 4 decisions to be made, and each of them there are 10 possible digits in there, and so we simply multiply 10 times 10 times 10 times 10, and we get 10,000 different ways of finding those last 4 digits.